It's your friendly math tutor, Miss C here, and today we are finding the point of intersection between two lines. So sometimes this is asked in another way, like solve this system of equations or solve these simultaneous equations. They all mean the same thing. So we can use substitution, elimination, or graphing to solve these. I think I am going to use elimination, because what I'm noticing when I look at my x's and y's, I'm noticing that my y values are both positive 3y. That means I just need to make one of them negative. And I'm going to go ahead and multiply this top equation by -1. So I end up with negative 2x minus 3y equals -12. And then I'm going to write the equation below exactly as it already appears because I am not manipulating that. So just as a reminder, you have to create an equivalent equation, which means that you multiply this one by every single term. Otherwise, you change the value of the equation. Okay. All right. So I'm going to do a quick check here. -3 plus 3y plus 3y is 0. We eliminated the correct variable. And now let's just combine the rest of our like terms. We have 5x minus x. 2x is 3x. And we have 14 minus 12, which is 2. I'm going to isolate x by dividing 3 on both sides. And we end up with an x value of 2/3. All right. So my next step is to pick one of my equations to substitute this back into. I'm going to pick the top equation because the numbers are a little smaller. So I have two. Oops, I don't have 2/3 there. Let me try that again. I have 2, and I'm going to substitute in 2/3 where x is, plus 3y equals 12. So there's a couple ways that we can handle this at this point. I'm going to simplify this 2 times 2/3. Remember, there's a secret 1 underneath this 2. We multiply numerator to numerator, and we get 2 times 2, which is 4. 1 times 3, which is 3. So we end up with 4/3 plus 3y equals 12. Now, if you hate fractions, what I'm going to do next is for you, I'm going to get rid of the 3 in the denominator. And the way I'm going to do that is I'm going to multiply this entire equation by 3, and that will put us into whole numbers. So 4/3 times 3 is 4, plus 3y times 3 is 9y. And then 12 times 3 is 36. So now we've got whole numbers, a little more easy to work with. So I'm subtracting 4 from both sides. I end up with 9y equals 32. And now I'm dividing by 9 on both sides. We end up with a y equals 32 over 9. So we want to check to make sure that this is in fact correct. So I'm going to go ahead and I'm going to plug both of these values into each equation. Okay, so you can see where I plugged 2/3 in. And then I'm going to be plugging 32/9 in here, and I should get out 12 if that works. And then here I'm doing the same thing, plugging 2/3 in for x and 32/9 in for y. And when I do that, I should get 14 out. I'm going to color code this so you can see what I did here. So, all right, here we go. I'm going to just pop this into my calculator, although you could do this the long way. So I end up with 4/3 plus, I'm just going to simplify this. This becomes 32/3. Actually, I don't need my calculator. So 4 plus 32 is 36 over 3, and that does in fact equal 12. So that works. This becomes 10/3. This becomes 32 over 3 again. And we're wondering if that equals 14. 10 plus 32 is 42 divided by 3. And that does, in fact, equal 14. So both of these answers are correct. We could also write these as a coordinate pair because this is where the lines intersect. So we know that when x is 2/3, y is 32/9. So this is the other correct way of writing our solution. Make sure to subscribe for more math videos. Till next time, remember, you've got this.